Hello everyone. Today we are going to start new topic, that is solutions. We have finished what? Gaseous state, and we are going to new lesson, solutions. Okay, ma. So what is the meaning of solution? Solution is what? The homogeneous mixture. The homogeneous mixture of two or more components. The homogeneous mixture of what? Two or more components. Homogeneous mixture of two or more components is called what? Yeah, solution. Suppose you take sugar solution. If you take sugar solution, sugar is dissolved in what? Water. Sugar is dissolved in water. When sugar is dissolved in water, we get sugar solution. That sugar solution is what? A solution because it is homogeneous mixture. It is homogeneous mixture of sugar in water. Is that clear? So homogeneous mixture of two or more components is called what? Solution. Now first see here. Now when you dissolve sugar in water, okay, to prepare what? Solution, sugar solution, which is what? Homogeneous, which is what? Homogeneous mixture. Homogeneous mixture of what? Sugar and water. Is that clear? So now here, this sugar solution is example of what? Solution now. And less in quantity, what we take here? Sugar we take less in quantity, or water we take less in quantity, sugar we take smaller in quantity. So it is what now? Solute. Solute. Whatever is taken in smaller quantities is called what here? Sugar solute. Relatively smaller quantity component is called what? Solute. And what is this water here? Solvent. Solvent. So which is major component? Major component is what? Solvent. Major component of solution is what? This one. And what is minor component? Minor component is what? Solute. Okay, so minor component is what? Solute. And now generally the weight, if you take weights, so weight of what now here? The solute. Weight of solute will be taken as W2. The weight of solvent will be taken as W1. Okay, W2 we can take, or WA we can take. Solute, WB. For solute we take what? WB or W2. WB or W2 means what here? Weight of solute. Weight of solute. So WB or W2. And W1 or what we take? WA we take for solvent. Weight of solvent we can represent like WA or W1. And weight of solute we can take W2 or WB. Remember. Okay. So the sugar is dissolved in water here. Sugar in water. Sugar in water type of solution it is. Now here, in this case, sugar is in which state now? Initially, it is in solid state. Water is in which state? Liquid state. The standard physical state of sugar is what? At room temperature, solid. The standard physical state of water at room temperature is what? Liquid. Now, what is the physical state of this sugar solution here? For this solution, the physical state is what? Liquid state now. Liquid state. The sugar solution is in liquid state. That means what now? The solution state and the solvent state. The solvent physical state and solution physical state will be same. Remember. Okay, in a given solution formation, whenever a solution is formed, homogeneous mixture is formed, the physical state of the solvent and the physical state of solution will be same. Now here, what is physical state of solute now? Solute is solid here, but so solution formed is in liquid state. Is that clear now? So it is about what now? Important basic information about solute and solvent. Solute and solvent. Is the concept clear so far? So it's about the formation of solution. Now, what we have taken now, weight of solution is what now? The total weight of this solution is what? Total weight of solution. Total weight of solution is equal to what now? W1 plus W2. Weight of solvent plus weight of solute together, what now? Total weight of solution. Now, total weight of solution means mass of solution only in a meaning. Mass of solution. Mass of solution is equal to what now? W1 plus W2 means mass of solvent plus mass of solute. Now, generally, for the same solution, what is density formula? Density of solution. Density of solution is equal to what now? Mass of solution divided by volume of solution, right? So volume of solution and what here? Mass of solution we can use here. So mass of solution upon volume of solution will give density of solution. In some problems, in some numerical problems, density will be given to you. Density will be given to you, volume will be given to you. Volume of solution will be given, density of solution will be given. They will ask you to find out what mass of solution. Mass of solution is equal to what? Density into volume. Volume into density is what now? Mass of solution. Mass of solution is nothing but here W1 plus W2 here. W1 W2 is equal to density into volume we take. Is that clear, ma? And also for this solute, we take mole fraction. Mole fraction. Mole fraction is given by which letter, ma? X. Mole fraction is given by X. For the solutes, what we take now? XB or X2. XB or X2 we take. And for this one, solvent, what we take? XA. XA means what here? Mole fraction of solvent. XB is what, ma? Mole fraction of solute. Already we know that basic thing. Mole fraction of solute plus mole fraction of solvent must be equal to what? 1. Must be equal to 1. 1 means what? Unity. Unity means what? 1. Okay. So the mole fraction of solute plus mole fraction of solvent must be always equal to 1. Therefore, now XA if you want to take, or XB if you want to take, XB is equal to what? Mole fraction of solute is equal to 1 minus XA. 1 minus XA. Is that clear, ma? Now, this sugar solution, the sugar solution formed is having how many components totally? The sugar solution has how many components? 2 components. What are they? 2 components. One solute, one solvent. 2 components are there here. One solute and one what here? Solvent. That's why it is called, this sugar solution is called binary solution. Binary solution. So binary solution will have how many components totally in it? So totally 2 components will be there in binary solution. Binary meaning what? Made up of 2 components, one solute and one solvent. Now imagine to this sugar solution we have added what now? Salt. Suppose sugar solution plus some salt. Now how many components are present? 3 components. Sugar solution contains what? Sugar plus water, and we added what now? Salt. Now how many components totally? 1 component salt, 1 component sugar, 1 component water. 3 components there. Now this solution is called ternary. 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 So what is the meaning of ternary solution? Ternary solution contains how many components, ma? 3 components. 3 components will be present in ternary solution. Ternary, we have to say. And what is if 4 components present? What is it called? What is the solution called? If 4 components are present, quaternary. Quarter, Quater. Okay, quaternary, Quater. Quaternary. What is spelling? Quaternary. Okay, so quaternary solution contains how many components? 4 components. Pentanary, penta means 5. Pentanary solution contains 5 components. Like this, the ternary, quaternary, pentanary, all these together called polynory, Poly. Polynory solutions contain what? More than 2 components. What is the name of solution here? Polynory, Polynary. Polynory solutions contain what? More than 2 components. More than 2 components. Okay. Always, if you take a ternary, if you take this ternary solution now, suppose in this ternary solution, how many components are there? 3 components. In these 3 components, among the 3 components, how many solvent particles will be there? How many solvents will be there? In the 3 components, only 1 will be solvent. Only 1 will be solvent. Remember, solvent will be always one solvent. Remaining 2 will be what? Solutes. Remaining 2 will be solutes. Okay. Suppose if you take sugar solution with what? Salt. Sugar solution with some salt. The salt and sugar both will act as what? Solute particles. And water will act as what? Solvent. So in this way, always the number of solvents will be 1. But the solutes may be 1 or 2 or more. That point we have to keep in mind. Once take the screenshot of this, ma. Take the screenshot. Yeah. So now next one. What is the definition of solution here? A homogeneous mixture whose composition can be varied within certain limits. A homogeneous mixture whose composition can be varied, can be changed. Varied means what? Can be changed, can be varied, can be changed within certain limits is termed as what? Is termed as a solution. True solution, remember here. What is called? True solution. In the previous class, we have discussed about what? True solution, okay, suspension, and what here? Next one, colloids. True solutions, suspensions, and colloids. These three, remember. What are the three types here? True solutions, next colloids, and suspensions. Now in case of colloids, the particle size will be 1 nanometer to 100 nanometers. The particle size will be what? 1 nanometer to 100 nanometers. If the particle size of solute is 1 nanometer to 100 nanometers size, it will be called colloid. If the particle size is less than 1 nanometer, if the particle size is less than 1 nanometer, it is called true solution. It is called true solution. If the particle size is greater than 100 nanometers, if greater than 100 nanometers, it is called suspension. Is that clear, one? If the particle size is less than 1 nanometer, the solution will be called what? The mixture is called what? True solution. If the particle size is between 1 nanometer and 100 nanometers, okay, the mixture is called colloid or colloidal solution also we say. Colloidal solution, otherwise simply colloid. And suspensions are what? Suspensions meaning what here? The mixtures in which the particle size will be more than 100 nanometers. Particle size will be greater than 100 nanometers in suspensions. So about this we will discuss in one lesson called surface chemistry. Which lesson we study about this? Surface chemistry, that we are going to discuss in detail later. Okay. For time being, remember that true solutions have the size of the particles less than 1 nanometer. So now here, what is homogeneous mixture whose composition can be varied within certain limits called true solution. So example of true solution is what? Example of true solution, sugar solution. The sugar solution is homogeneous mixture. After dissolving sugar in water, sugar solution is formed. Now, can you distinguish between sugar particles and water particles separately in sugar solution? In sugar solution, if you observe, can you separately identify the particles of sugar and particles of water? No. The sugar will go into solution thoroughly, completely. Sugar and water thoroughly mixed. The homogeneously mixed here. That's why we cannot identify sugar particles and solvent particles. That's why it is what? No, homogeneous mixture, sugar solution. So the sugar solution, salt solution, all these are what? True solutions. Okay. Next, the constituents of a solution cannot be separated. The constituents meaning what? Components. Solute may be one or more, na? Solutes and solvent. One solvent only will be there. One solvent is one constant of the solution, and solutes may be other constituents. So these constituents means solutes and solute particles and solvent particles cannot be separated by filtration. Filtration is physical method. Cannot be separated by physical methods like filtration, settling, or centrifugal action. All these things here. These all are what now here? Physical methods. By physical methods, we cannot separate the solute particles and solvent particles. Remember, the solute particles and solvent particles cannot be separated from each other by physical methods such as filtration, settling, and centrifugal action. So all solutions are characterized by homogeneity and absence of settling, and the molecular, otherwise ionic state of subdivision of the components. Subdivision of the components. That means try to understand here. First one, what now? Solution, particles of solution, solute and solvent of a solution cannot be separated by physical methods like filtration. Filtration we know. We filter the tea now. We filter the tea. Okay, the tea dust will be separated from tea. Okay, after filtering, on the filter, whatever is obtained, the tea dust is called what now? Okay, it is residue. And whatever we drink tea is called what? Filtrate. What is that? Filtrate. Whatever we drink is filtrate. Whatever is obtained after filtering the solid is called residue. Same thing, if you allow the tea without filtering, if you allow the tea to settle at aside for some time, if you keep the tea in a glass for some time, what happens there? The tea dust particles experience gravitational force of attraction, and the tea dust particles will go to the bottom of the glass and settle at the bottom. Then we can drink tea. So like that here, settling will be what now here? The settling of the heavier particles of the solution at the bottom of the vessel. That is settling. This settling cannot be used here. Now tea, in case of tea, the tea dust particles can be separated from a tea now. So it is what now here? Heterogeneous, we have to say. But here now sugar solution, if you allow the sugar solution to stand for some time, will the sugar particles be settled at the bottom? No, the sugar particles from sugar solution cannot be settled at the bottom. Settling will not take place. By settling process, we cannot separate sugar particles from water, from sugar solution. And by filtration, if you take sugar solution, if you pour on the filter, the tea filter is there na? On the tea filter, if you pour the sugar solution, can you get any residue particles? Can you get any solid particles on the filter? No. That means what, by filtration we cannot separate sugar from sugar solution. Means we cannot separate solute from solvent by filtration, by settling. And centrifugal action meaning what? Centrifugal action means, suppose you take what now here, blood test. Example of blood test. When we give blood for blood test, they take the blood in test tube and they keep in centrifugal machine. Centrifuge, that is called centrifuge. In the centrifuge, that is centrifugal machine, they keep what, the test tube with blood, and they will rotate with high speed. When they rotate the plate with high speed, what happens now? All the particles, heavy particles like the blood cells, all the blood cells of the blood will be settled at the bottom by centrifugal action. By this centrifugal action, the blood cells, the solid blood cells in the blood will be settled at the bottom. Then we separated now here. That is centrifugal action here. So blood is not true solution. Blood is not the true solution because we are able to separate what? Blood cells, solid particles from the blood. So by centrifugal action, we cannot separate the solute and solvent. By settling process, we cannot separate the solute and solvent. By filtration also, we cannot separate solute from solvent. Okay, so true solutions, in case of true solutions, the components of solution cannot be separated by filtration method, by settling process and centrifugal action. These are physical methods of separation. And now what we give another point here, all solutions, all true solutions. Whenever we say solution, you take it as true solutions. Remember, all true solutions are characterized by what? Homogeneity. Homogeneity means what? Homogeneously, thoroughly mixed. Homogeneously, solute and solvent particles are mixed. Means thoroughly the solute and solvent particles are mixed. That is called homogeneity. That is why it is called homogeneous mixture, true solution. Next, absence of settling. Absence of settling. That means what? The particles of solute in the true solution will not be settled at the bottom of the vessel. That is the absence of settling. And what? The molecular or ionic state of subdivision of the components. Suppose if we dissolve NaCl into water, NaCl in water, we get what? Na plus Cl minus. Okay. Further, Na plus particle will not dissociate further. Cl minus will not further dissociate. Subdivision of Na plus will not take place again. NaCl divided into Na plus Cl minus and dissolved. But subdivision of Na plus will not take place here. And if you dissolve glucose particle, glucose formula what? C6 H12O6. The glucose molecule, when it dissolve in water, the glucose molecule will not dissociate. No subdivision of water molecules. No ions. No cation. No anion. The same molecule, C6H12O6 molecule remains the same molecule with same composition. Okay. So these are all points we have to remember. Now this what here? Colloid and suspension there now. The colloid and suspension. Colloids and suspensions are both are what now here? Heterogeneous mixtures. The suspensions and colloids. The suspensions and colloids are together called what? Heterogeneous mixtures. Heterogeneous mixtures. What is the meaning of heterogeneous mixture, ma? When solute and solvent particles means what? When the particles are constituents are not thoroughly mixed with each other. When the components are not thoroughly mixed with each other in the given mixture, that can be called heterogeneous mixture. Examples what? Colloids and suspensions. Chalk piece dust in water, suspension that is. And milk, blood, these are what? Colloids. True solution what? Sugar water, sugar solution, and salt solution are true solutions. So always recall these examples whenever you see the true solution or colloid or suspension. Okay. Next one. Ice means what? Yeah, solid here. So when this moment, yeah. So when the solution is composed of only two chemical substances, when the solution is composed of only two components, two chemical substances, it is called what? It is termed as what? Binary solution. It is termed binary solution made up of two components, one solute, one solvent. Similarly, it means solution. The solution is called ternary if it is made up of three components, and quaternary if it is composed of three components, quaternary. If it is composed of four components, quaternary. If three components are the ternary, if four components are there, quaternary. Three components will be called ternary solution. If four components are present, that is quaternary solution. Suppose you take here sugar solution with salt and lemon. Sugar solution with salt and lemon water. So lemon particles will contain citric acid. Lemon will contain what? Citric acid. So citric acid is one solute, salt is one solute, sugar is one solute, and water is what? Solvent. Water is solvent. Like this, the lemonade. Lemonade means what now? Nimmarasam in Telugu. So it will contain what? Water, sugar, salt, and lemon juice. These all four components are there here. That's why it is what? Quaternary solution. Example. Is that clear? Next. So here, if four components are there, quaternary. If three components are there, ternary respectively. Thus, a solution may be regarded as a single phase containing more than one components. Single phase, but containing what? More than one components. Single phase meaning what here? Suppose you take in the first example here, the sugar solution is in single phase. Single phase means what? Which phase? Liquid phase or solid phase? Liquid phase. Only in liquid phase it is. When you see the sugar solution, when you look at the sugar solution, it will appear in which state, ma? Liquid state only. What is the single phase of the sugar solution? Liquid phase only. But it contains how many particles? Two types of particles. Two types of components. Solute sugar and solvent water. Two components are there. But we cannot separately see the sugar particles from water particles. That means what? The total solution will be always in what? Single phase. And the phase of solution and phase of water means solvent. The phase of the water and phase of the solution will be same, liquid phase. For any solution, the physical state of solution and physical state of solvent will be similar. Okay, next one. Now, this is what ternary and quaternary solution. If five components are there, it is called what? If a solution contains five components, what is that called, ma? Pentanary solution, like that. Now here, solvent and solute. Which is major? Solvent is major, solute is minor component. Every solution consists of a solvent and one or more solutes. And solvent in a solution is its constituent substance, the solution's constituent substance, which has the same state of aggregation. The same state means physical state, the same state of aggregation as that of solution. If solution is in liquid phase, the solution is in liquid phase, the solvent will be in liquid phase. If the solution is in solid phase, the solvent must be in solid phase. This way we have to understand what now here, the physical state. Generally, the component present in greater amount than any other, okay, or all the other components is called what now here, solvent. Among all the components, if any component is present in greater amount, that will be called what, solvent. So solvent is called major component. What is solvent here? Major component. Major component of solution is what? Solvent. Always only one solvent will be there for any solution. For the solubility of solids in liquids. For the solubility of solids in liquids. Solids means, example, what now you take sugar. Sugar is the solid. Sugar solid in what now? Liquid water. In liquid water, the sugar solid is dissolved. So that is called solubility of solids in liquids. So in the case of solubility of solids in liquids, where the liquid is present in large excess over the solid. The liquid means water here. The water is present. The water is present in large excess over what? The solid sugar. Or the solid sugar, which is more in quantity, the water will be more in quantity. Is that clear? So now how to define the solute now? How to define the solute? Tell me. The minor component of a solution is called what? Solute, simply. The minor component of solution is called solute. Otherwise, the component of a solution which is, okay, smaller in quantity is called what now here? Solute. So in a solution, there may be one solute or two solutes or three solutes or excess. Okay, more than three solutes. Okay, so it is about solvent and solute. Is that clear, ma? Now, all the three states of matter, that is gaseous state, liquid state, and solid state, may behave either as solvent or solute. So the solute may be solvent, solute may be in gaseous state, solute may be in liquid state, solute may be in solid state. Otherwise, the solvent may be in gaseous state, solvent may be in liquid state or solid state. That is what they said here. Depending on the state of solute, or solvent, physical state of solute and solvent, mainly there may be the following 7 types of binary solutions. So generally the lesson name solution meaning what? Solutions lesson name means what? Here binary solutions only. We study about which lesson? Binary solutions only. We don't study about ternary solutions properties and quaternary solution properties. We study about binary solution, which contains one solute, one solvent. So how many types of binary solutions? 7 types. Based on what? Depending on what? Depending on the state, physical state of solute and physical state of solvent. Okay. So the first type is, check it here. So gas in gas. So gas in gas type of solution. So how to listen? Gas in gas type of solution. Now gas is what now? Your solute. The physical state of solute is gas. The physical state of solvent also gas. Gaseous state. So solute is what now here? Minor component. Minor component. And what is solvent here? Solvent is major component. Solvent is major component. This point keep in mind. So solvent is major component. Solute is what? Minor component. Now gas in gas type of solution, example what? Air. In air what will be there? Oxygen gas and CO2 gas mainly, and organelles will be there. So oxygen and CO2 gas, these two will be present in nitrogen gas, isn't it? So nitrogen gas, what here? Major quantity, 78%. What will be there, ma? nitrogen will be there. 21% what will be there? Oxygen will be there. And 0.03% what will be there? CO2 will be there. So now here, two gases, suppose. Argon also will be there. Argon also will be there. But remember, mainly oxygen and CO2 will be present in nitrogen, we take suppose. In this case now here, oxygen is one component, CO2 is one component, and nitrogen is another component. Now, which is present in large excess? Nitrogen is large excess. So it must be called what now here? Solvent. What is physical state of solvent here? Gas. And what are the physical states of solutes here? Two solutes, oxygen solute, CO2 solute, gaseous state. So gas in gas type of solutions, example what? Air. Okay. Next, gas in liquid, gas present in liquid. So solute is gas, solvent is liquid here. Okay. So example what? Aerated water, aerated water. CO2 gas dissolved in water liquid. CO2 gas is present in liquid water. So it is called what now here? Gas in liquid type of solution. So it is what? Aerated water, cool drink, aerated water. And gas in solid type of solution, gas in solid. Okay, example what? Hydrogen gas, hydrogen gas in palladium metal. Palladium means what? PD. So in palladium metal, there will be palladium atoms like this. Palladium atoms are closely packed in the metals. In the metals, the metal atoms are closely packed. But between these spheres, what will be there? Some gaps will be there. These gaps are called interstitial gaps. Interstitial gaps. What is that one? Interstitial gaps. Interstitial gaps are also called VOIDs, voids, empty spaces. VOIDs, voids, otherwise interstitial gaps. Interstitial gaps, otherwise voids. So now here in these gaps, the hydrogen gas will be filled. What will be filled here? Hydrogen gas will be there here. So hydrogen gas will be there in the gaps between the palladium particles. So this type of solution is called what now? Hydrogen present in palladium. Okay. Now what is the solvent physical state? Solvent physical state is what? Solid. Palladium na here. Palladium solid. Palladium solid is solvent here. Right, ma? And hydrogen is solute. Hydrogen is solute. So hydrogen is solute in gaseous state. Palladium metal in solid state. Okay. Next, liquid in liquid type solution. Liquid in liquid type of solution. So in this case now here, example what? Alcohol, liquid. Alcohol is what? Ethyl alcohol, C2H5OH. Ethyl alcohol in water. Ethyl alcohol in water. Alcohol is in liquid state. Water also in liquid state. Next one, benzene liquid. Benzene liquid in toluene liquid. Toluene, TOLUENE, toluene. So toluene liquid. Is that clear, ma? So toluene liquid, alcohol in water, benzene in toluene. These two are what now here is. Toluene formula what? C6H5CH3. C6H5 bond CH3. This is called toluene. What is benzene in a formula? C6H6, benzene. Alcohol formula what? Ethyl alcohol, C2H5OH. So ethyl alcohol in water, benzene in toluene. Is that clear, ma'am? Next, solid in solid type of solution. Solid in solid type of solution. Example what now? Sorry, liquid. Liquid in solid. Liquid in solid type of solution. Example what? Mercury liquid. Liquid metal na mercury. Liquid metal. The mercury is what? Liquid metal. This liquid metal is present in zinc. Okay. So liquid metal is present in zinc. This is called zinc amalgam. What is this called? Amalgam. Amalgam means what? One component must be mercury. In the solution, one component must be what? Mercury. Then it is called amalgam. Now, what is along with mercury here? Zinc is along with mercury. No? So we can say this one zinc amalgam. Zinc amalgam is here. What do you say? Zinc amalgam. This will be represented like this. ZnHg. Zinc amalgam it is. Is that clear, ma? Next one. Solid in liquid type. Solid in liquid type here. Solid in liquid type of solution. So in this case, example what? Sugar solid in liquid water. And common salt, NaCl solid in liquid water. Next, solid in solid. Solid in solid. Example of alloys. Alloys means what? Mixture of two or more metals. Mixture of two or more metals is the alloy here. Suppose you take here bronze. Bronze is one alloy here. So bronze is made up of copper and tin. Copper and tin. Sn means what? Stannum, Latin name. Tin and copper. These two metals together form what? Bronze alloy. Bronze alloy. In this, what here? Copper is in solid state. Tin also, metal also is in solid state. So these two metals in solid state will be melted and will